Hi everyone, my name is Anastasiia and I'm happy to represent the University of Bergen and Media Futures Research Center with this work. And we've investigated different approaches to mitigating popularity bias that was talked a lot today already.
Yes, thank you very much and sorry for interrupting.
It's okay. So it has been talked already today about popularity bias, that there is a certain phenomena where already popular items just keep getting more into recommendations and keep getting more exposure, while some less popular items receive less exposure and end up not even getting into recommendation lists for users on platforms. Why exactly is it bad? There are several let's say, ways to define the difficulty of this. There are some ethical issues, like items deserve exposure or users deserve exposure in certain platforms. There is also an industrial value to mitigating a popularity bias. When increasing the diversity of the recommendation, we can potentially increase the satisfaction of the user using the platform. While the opposite can lead to dissatisfaction and eventually the user leaving the platform. It could also cause the same effect for the companies or people providing their services on the platform, and when people are getting recommended on the platform. And when they don't receive the exposure they assume they deserve, it might also lead to the withdrawal of these companies or people from the platform. There has been different types of solutions presented in the past decade or so of the research in this field. Some solutions are applied to pre-processing of the data. Some solutions are in-modal solutions when the algorithm is altered in some certain way to try and mitigate the popularity bias. And some re-ranking approaches or some approaches that are aiming into representing the recommendation result in a different way to maybe also affect the presentation or location bias. In our work, we've concentrated on the re-ranking process since we're working with industry partners at our center, and possibly re-ranking is the less costly approach for industries to implement it. It would be just a layer that they put on top of their models. We focused on the work of Abdullahpuri that was mentioned already previously as well. And we've reproduced the re-ranking approaches from this paper, as well as trying out the calibration approach that they provided. How re-ranking approaches normally work, the original model creates a large recommendation list, which is later reshuffled somehow or reworked and reorganized and then narrowed down to smaller recommendation lists that the user receive in the end. The recent calibration approach that was offered by Abdullahpuri aims to consider the user preference towards popular or less popular items. They've defined three different user groups, so-called mainstream lovers, the people who prefer to consume more popular items, then the user who prefer to consume more niche items, and the users in between who like both. And the assumption is that treating all those different user groups differently, giving different approach to recommendation to these users, equals to fairness towards all those user groups. It has been also observed that anytime the popularity bias is being attempted to mitigate, there is a certain trade-off between accuracy and fairness in this case. So in this plot, you can observe how the accuracy goes down as soon as we try to mitigate the popularity bias more. And it has been observed in different fairness issues as well. We've conducted some preliminary experiments trying to observe how different recommendation techniques affect those user preferences. On the left, you can see the regional state of user preference between different groups. G1 is the mainstream lovers, G2 is the middle in between users, and G3 is the niche lover users. And you can see how different algorithms, like most popular algorithm, absolutely disregards this user preference and just recommends all the popular items to all the users, while algorithms like BPR or ALS or KNN also disregard this preference to a certain extent, but differently. So the research questions that we put in front of us were to just observe what are the current state-of-the-art re-ranking approaches to mitigating popularity bias, what are the existing metrics proposed to measure the effectiveness of these methods, and how well these methods perform according to the chosen metrics. Our evaluation setup, we ended up choosing ALS, which was the baseline recommender, and we were trying to simulate the recommendation system of our industry partner TV2. TV2 is the Norwegian broadcaster, which is basically the Netflix of Norway, and they have recommendations for movies and series and news. We concentrated mainly on movie recommendation on their platform. So we've used the dataset provided by them on the user viewing sessions. And we also used the standard movie lens dataset for baseline comparison. We've re-implemented 3 different re-rankers. I'm going to call them FS, XQ, and CP. And CP is the calibration approach, while the others are just general popularity bias mitigation approaches. They attempt to lower the general popularity of recommendations, regardless of the user. We defined a set of metrics that would help us to investigate this phenomena from different points of view. We used precision to calculate the accuracy. We've used the user popularity deviation to see how important the user preference is for the recommendation, how far the distribution of the popular items in the user history and in the recommendation that the user receives. We used several different long tail exposure metrics like average recommendation popularity or average coverage of long tail items to see how much exposure the tail items receive. And then in the end, we also used equal item exposure metrics like Gini index and aggregate diversity to see how diverse in general the recommendations are that the users receive. So here you can see the results, the same analysis of the user groups and the recommendations that they receive. You can see the regional user history groups and the percentage of popular and less popular items that they have. And then on the very right, you see just pure baseline ALS recommendations, which generally tend to recommend more popular items to all the user groups. XQ is general popularity bias mitigation technique. It lowers the popularity, which we can observe for all the user groups represented here. And the CP is a calibration method that tries to adjust the percentage of popular and less popular items according to the user preference. And it could be clearly observed in this plot, and it tries to adjust the recommendation to the original data. Here are all the metrics represented that we've collected after performing the experiment, and all those numbers, there is no clear answer from these numbers which method performs the best way. And the general conclusion that we drew from this experiment is that you have to clearly define the aim, what you're optimizing your system for. And depending on that, you should choose the method you apply for popularity bias mitigation. For example, if you really strive to adjust your recommendations the most to the user preference, you should choose calibration method. If you just want to boost tail items and give them more exposure, you should choose the XQ method, which just lowers the popularity of the items and gives them more exposure to the tail items. And if you're aiming to balance out those two different effects, then you should choose the FS method, which seems to be more or less middle ground between the two different approaches that I've mentioned before. For the future work, we've defined that it could be interesting to try out the same experiment in different domains, because different domains might be unpredictably providing other results. We would expect that, for example, music, book, or news recommendations could be similar. However, some news recommendations could be absolutely different, and it would be interesting to look into that. As well as the offline evaluation that we've performed showed how some results currently, but it would be really interesting to see how the situation changes in the online evaluation. So our current future plans is to conduct an A/B study with TV2 on the real system and see how mitigating popularity bias in certain way leads to improvement of user satisfaction, or improves user attainment, and helps with user interest in the platform. So yes, this was my presentation, and thank you so much for coming and listening to me.